Okay, so first let's just plug in f of -2. So f of -2. So everywhere there's an x, I'm going to plug in a -2 with parentheses. So minus -2 squared. Make sure to do order of operations here. So this would be -4 minus +4 there. So subtracting, that's actually going to be a +4 when you square a negative. So that gets -8. Remember, your answer is written f of -2. So it's not just, that's your answer. F of -2 is -8. So let's do the next one. 2 plus h. So f of 2 plus h. So everywhere there's an x with parentheses, I'm going to plug in 2 plus h. So this will be 4 plus 2h when I distribute minus. Let's go ahead and FOIL this. So if you FOIL that, I'm going to just do that in my head, but you have to first outside, inside, last 2 plus h times 2 plus h, which would be 4 plus 2h plus 2h is plus 4h plus h squared. And it's very important that all those things are being subtracted now, right? So we get 4 plus 2h minus 4 minus 4h minus h squared. So with functions, you don't really have to simplify or factor this, but we do need to combine like terms after we kind of multiply it out. So -h squared, 2h minus 4h is minus 2h, and 4 minus 4 is 0. So we just get that is our answer for f of 2 plus h. On the domain of the function, so domain, we're looking at denominators and square roots are causing issues. That's all we know of right now. So the first thing I might do is just rewrite this with the denominator factored, because that will help us. There's nothing that seems wrong about the numerator as far as, no square roots or anything up there. So it looks like there's two values that are going to be excluded. X can't be 1, X can't be -1. So the answer is all reals except X cannot be equal 1 and x cannot equal -1. Here again, the part we're concerned about is the radicand there. That radical, a square root, a cube root can be negative, but a square root, an even root, can't be negative. It has to be non-negative. So you take whatever's underneath there. In this case, x minus 3, and to say it's non-negative, you say greater than or equal to 0. It takes one step to solve. So we get x greater than or equal to 3, and that's our domain. So this is our domain for the first one. That's the domain for the second one. So this one, make sure when you plug it in, you only get one answer, not 3. There's 3 pieces, but you're only going to plug into one of those. So f of -3. So which domain does that fit into? Not the first one, because it's not smaller than -3. I think it does fit into this domain, right? So, -3 is less than or equal to -3. That's true. So you're going to plug into this function for that one. So f of -3 would equal negative. Instead of x, you're going to plug in -3, which is +3. So we get +3. Now let's do f of -4. So, or f of +4. So f of 4, that seems to fit into this domain. So you're going to plug into this function there. So f of 4 equals, instead of x squared, it's going to be 4 squared, which is 16. That's the piecewise function. So because my pen right here doesn't have an eraser, I'm going to have to actually think about not just drawing the line, but erasing, but actually think about the domain from the start. So that's we'll draw back, otherwise you might just erase. So 2, that's going to be a horizontal line at 2, at y equals 2 there. So, but I only want the part where x is -2 or less. So -2 or less, I think that's going to be a closed circle at -2. And a horizontal line looks something like that, right? So I don't need the whole horizontal line. I only need the horizontal line when x is less than or equal to -2. If you know what this graph looks like, we know their x squared graph. We kind of have that one memorized. If you just flip all the x values or the y values, make them negative, then you're going to have this graph, and it's between -2 and 2. So -2 is going to be an open circle down here. So over 1, down 1, over 2, down 1, 2, 3, 4. So I think it's going to hit right there as an open circle. Right here is a closed circle, closed circle, closed circle, and open circle down here as well. And if you're having trouble doing that, the way we do that when the a value is negative, if that didn't make sense to you, you start with the points you know and love for that graph: 2, 4, -1, 1, -2, 4, and you multiply all the y values by -1. So that's well, that's still 0. That's -1. That's -4. That's -1. That's -4, and you plot those points. And I made those 2 points where x is 2 and -2 open circle because this is not equal to 2 or -2. It's less than or bigger than those two. Okay, and this one's written kind of a weird form. It'd probably be easier if you thought of this as -x plus 4, so it's mx plus b form. That make more sense. The y-intercept is 4. Can't really graph that right now because it's not part of the domain, but the slope is -1, so I'm going to go in a negative down 1 over 1 to the right, down 1, 1 to the right. That's going to be a closed circle right there, and the arrow's going this way, something like that. Again, normally I would draw the whole line and erase it. I just don't have that capability right now with this particular setup. So to solve this, again, we solve it for y and tell me if it equals one thing or not. This takes one step. You would take the fourth root of both sides. When you take the fourth root of both sides, don't forget that's an even root, so you're going to have to put plus or minus on one side. As soon as you put plus or minus on one side, you go, oh, that's not one function, that's two. And so this is definitely not a function. So this is no, not a function. That's basically saying, is this a function? Is y a function of x? Is it a function? No, it is not. Okay, to solve for y, oh, it only takes, wow, both these only take one step. So cube root. Now, cube root, you don't have to do anything special. So cube root of x minus 5, there's no plus or minus here, so it's just y equals that. And this would be, yes, it is function because I got one thing. I got something I could graph in my calculator. I got one thing. So you're basically just solving for y. Determine the average rate of change for the function. Okay, so you're going to use that formula f of, use the function notation here. So let's just try that. So it's going to be f of 10 minus f of 0, f of b minus f of a over b minus a, so 10 minus 0. So then you have to kind of figure out f of 10 in order to plug it in right there. So f of 10, let's just kind of figure that off to the side. That f of 10 would be 4 times 10 squared minus 10 plus 5. So that's 4 times 100 is 4 minus 1,000 plus 5. So it's negative 600 plus 5 is negative 595. Negative 595. So I have negative 595 minus, we're subtracting now, f of 0. Well, that should be easier to plug in. So we get 4 times 0 squared minus 0 to the third plus 5, which is just 5. So minus 5 over 10. Oh, this works out nicely. So we get negative 600 over 10, which is negative 60 over 1, which is negative 60, which I think would be the answer here. There's a slope of a rate of change of negative 60, basically. I didn't leave any room for number 9. That's funny. So let's try to do this. So I probably should have left a little room there for number 9. So I'm looking at number 9. So we're going to do x. I'm going to do the work up above. So f of 2 is equal to 3 times 2 squared minus 2. So 3 times 4 is 12, minus 2 is 10. And then 2 plus h, this is the f of 2 plus h equals 3 times 2 plus h squared minus 2, which is 3 times, let's FOIL 2 plus h, so that would be 4 plus 2h plus 2h is 4h plus h squared minus 2, which if I distribute 12 plus 12h plus 3h squared minus 2. Put things in the right order and just combine like terms so you don't have to factor the same thing. 3h squared, 3h squared plus 12h plus 10 would be our answer. Sorry about not giving any room there. Okay, the graph of f is given. What is f of 2? So when x equals 2, it looks like it's a point right there at 2 comma 1, 2, 3, 4, negative 4. So this would equal negative 4. It's asking for a y value there, basically. When f of x equals negative 4, so it's saying when the y value is negative 4, what would x be? Well, it looks like there's actually two values here where the y value is negative 4. So it looks like at 4 comma negative 4 and 2 comma negative 4. So when x equals 2 and when x equals 4. So you're kind of like mentally drawing a line wherever the y value is negative 4 and saying, where does it cross this function? It crosses twice. And those are the two x values I need. What is the domain? It looks like, I'm going to say it in interval notation, so it looks like negative 2 is the lower bound, but not including negative 2, and 1, 2, 3, 4, 5. On the right, it does include 5. It has a closed circle there. So negative 2 to 5. You could say it this way, negative 2 less than x less than or equal to 5. What is the range of f? So how low does it go? How high? 1, 2, 3, 4, 5. So negative 5 would be the lower bound, and that does include that value, comma. Negative 1 is the highest it goes, and it does include that value. Or you could say it this way, negative 5 less than or equal to y less than or equal to negative 1. So we're going to draw the graph of this one. So let's go here and draw this. So and find out where it's increasing, decreasing. We may have to adjust our window. We'll have to see x to the 4th minus 3, x to the 3rd plus 2x minus 2. Okay, I don't need to see that anymore. I'm just going to hide it. Okay, I'm going to adjust this one. It doesn't need to be quite so big there. So negative, negative 3, negative 4. Let's make it 5, I guess. Negative 10, I'll make it a little bit lower. Okay. So now I have a nice window. You don't have to adjust your window. I just prefer to. So menu 5.1 is trace. Find the local minimums or maximum. It looks like there's a minimum. Maximum. If I go to the right a little more, I find a local minimum there. Just going to put this up here so I can see it a little easier. I'll put this over here so you can see it a little easier. Okay. Oh, it doesn't bring to that. Okay. So let's just use this to, again, we're going to use the x values, not the y values. The domain values determine when it's increasing and decreasing. So that first section of the graph, it looks like it's going down, so it's decreasing. When, let's see, let's go from negative infinity to the x value of negative 0.432, negative 0.432. And then for a short segment there, from that point to that point, it looks like it's increasing. So I'm going to label that by its x values, by its domain. So it starts at negative 0.432 to 0.541. And then it decreases, it looks like from that point to that point, it's going down. So I'm using the x values there. So that's another, so that would be 0.541 to 2.14. And then it increases the very last part there from 2.14 to infinity. And you've got no calc. Okay, let's just do transformations. So this negative means the parabola has been flipped down. So if you, like, I might just memorize this point, go 0, 0, 1, -1, 2, -4, -1, -1, to -4. So I just took those 5 points and reflected them over the x-axis. This, of course, is going to make every point move 2 units to the right, because x minus h, x minus 2, so h is positive 2. The vertex is going to be at 2, comma 0. K is really 0 there if you want to think about it that way. So I'm going to move this vertex 2 units to the right. That's my new vertex right there. This point moves 2 to the right. This point moves on top of this other point. So those our points are now in this graph. This moves to there. I'm trying to make these points a little thicker. And this point moves to there. So these 5 points now make up the graph, roughly like this. And this one, so it's interesting because it's not in front, it's attached to x. This is going to make the parent graph reflect over the y-axis. So that point 0, 0, 1, 1 will reflect to here, and 4, 2 will reflect to negative 4, 2. So that's after just that transformation. Everything moves up 1 because k is 1. So I'm going to move that point up 1. This point moves up 1, and this point moves up 1. It just made them thicker just so you can see the difference. And so that would be my new graph. And this one's probably the toughest just because it's got a lot going on, especially with the a value. So if you do absolute value, if you know your parent graph, like 0, 0, if you know those points, 1, 1, 2, 2, negative 1, 1, negative 2, 2. So all the y values are being multiplied by negative 1/2. So that, well, that's still 0. This is now negative 1/2. This is now negative 1, negative 1/2, and negative 1. So to plot those points, 0, 0, 1, negative 1/2, that's kind of hard to plot somewhere in there. I'm sorry, it's down here. Sorry, I went the wrong way. It's not there. So 2, negative 2, something like that. Those 5 points kind of opening downwards, but very wide. Everything moves up 3, so all of those points, the new vertex will be right there. That's the vertex. This point moves up 3. This point moves up 3. All 5 of those points move up 3, and pretty soon we have our graph. It's hard to write. That's a straight line. It's a V there. Should be V-shaped. I just kind of messed up. Okay. Determine whether it's even, odd, or neither. So the test is plug in negative x. Let's do that. For both of them, it's the same test. Negative x minus 4 over negative x. And let's just see how that changes the term. So this term became negative. So this term changed sign. This is now going to be plus 4 over x. So that term changed sign as well. So both of them changed. If they're both the same, it would be even. If everything's same, everything's different. So this is going to be odd. So this is an odd function. And you knew x to the first there. It was weird because of the denominator, but it has x to the first there. So I was leaning like maybe this will be odd, but I wasn't sure. But it does pass the odd test, so it should be an odd function. Let's kind of look at it. It's not part of what you'd be asked to do. I just want to see the graph just to see if it does look odd. So x minus 4 over x. And if you odd function is symmetry with the origin, and it does look symmetrical with the origin. If you kind of twist that graph around 180 degrees, looks like it would fall onto itself there. So I do think it is odd. Just wanted to see what the graph looks like. I had no idea what the graph looks like. It's a very weird looking graph. But again, if everything's the exact opposite sign, it's going to be odd. And it is. So first we're just adding the functions. So f plus g, make sure you label these. So f plus g, we'll just be adding them. I don't think you have to simplify anything here. 2x plus square root of x minus 1. F minus g, make sure to label it 2x minus square root of x minus 1. Not a whole lot happening there. Multiply the two, okay? F times g. So this will be 2x times square root of x minus 1. So it also mentions their domain. So what are the domains of these two functions? So the domain of this first function is all reals. The domain of this one, let's just kind of figure that one out off to the side here. So that would be x minus 1 greater than or equal to 0. So x is greater than or equal to 1 when you solve that. So when you meld those two ideas together, all reals and x greater than or equal to 1, you get x greater than or equal to 1. So the domain on all these would be x greater than or equal to 1, x greater than or equal to 1, x greater than or equal to 1 are the domain on all three of those. Those are kind of easy domains to get there. After divided by g, we might have to think about one more value that's been excluded or something here because it has a denominator, so it's adding a new kind of feature to this. So f divided by g, the actual thing of this is not bad. It's just 2x divided by square root of x minus 1. The trouble comes into thinking about the denominator because now I have two things going on. You have a square root and you have a denominator. So what value can x be that would make the denominator 0? And you can probably see x can't be equal to a positive 1 here. So I'm going to take this domain but say, hey, x can't be negative, can't be positive 1. But here, x can be positive 1. So I'm going to change this and say x is greater than, not greater than or equal to, but just greater than 1. So that would be my domain. That's probably the toughest part because I have to take this excluded value that comes from the denominator and say, okay, let's meld that into this and say, well, can't include that. So we're just plugging in a number here to start with. So g of negative 3, let's plug that in a g function. So this would be, let's see if we can do that in our head. 2 times negative 3 is negative 6 minus 4 is negative 10. I just did that in my head. Hopefully that you follow that. Now I'm plugging that into the f function everywhere there's an x. So this would be, instead of x squared plus 1, it's going to be negative 10 squared plus 1, which is 101. Positive, because a negative number squared. F of x. So we're going to have f of, instead of f of x, I'm plugging in f of x, which is x squared plus 1. Now, everywhere there's an x in that function, I'm going to plug in an x squared plus 1. So instead of x squared plus 1, it's going to be x squared plus 1 squared. I'm going to have to FOIL that. I'm going to try to do that in my head, so help me out here. So this would be x to the 4th plus x squared would be plus 2x squared, plus last would be 1, and then plus 1 because it has there. So my final answer would be x to the 4th plus 2x squared plus 2. And that would be f of x. Determine whether it's 1 to 1. So You can do this a couple different ways. So let's just try to do this algebraically. This would be the kind of sure way of doing it. Sometimes the graph can be a little deceptive. So to do this, we could solve for y. Well, because y is really f of x, right? Minus 2. So is it a function? Yes, it's a function, but is it a one-to-one function? Now we'd have to solve for x to see if it also equals one thing there. We solve for y, it's one thing, that's a function. So solve for x. So let's add 2 to both sides. So we get y plus 2 equals x to the fourth. Take the fourth root of both sides, and when you do that, you have to do what? Plus or minus on one side. This is not one-to-one. It is a function, but it's not a one-to-one function. So it is a function, yes, but not one-to-one. Not the as good a way, but it's not bad, is you could graph it and kind of see if it's one-to-one or not. So x to the fourth minus 2. Graphically, it should pass two tests, the vertical line test, which it seems to pass with flying colors, and the horizontal line test, which it seems to fail pretty massively there. So it doesn't pass both tests. Sometimes it's hard to see in the calculator. That's why I showed you the algebraic test. Solve for x and see if you get one thing, you get two things. It's not going to be special one-to-one function. So this doesn't pass the horizontal line test. So that's not a one-to-one function, although it is a function. Properties of inverses to show the f. So when it says show that, it means these are inverses. I don't have to like try to convince you of that. You just have to prove it. And so we do that by composing the two functions and see if we get x, I think is what we're supposed to get. So if we do f of g of x, we should get x. Well, let's see. So f of, what is g of x? Let's plug that in. So that's x minus 1 to the third power, to the 1/3 power, I guess. 1/3 power. Okay, so we're going to plug that into the f function everywhere there's an x there. So that'll be, instead of x cubed plus 1, it's going to be x minus 1 to the power of 1/3 cubed. So now when you have power, 1/3 to the third power is actually to the first power. So now I have x minus 1 plus 1 equals x, which of course touches x equals x. It passes the test, but guess what I have to do? I have to compose it the other way as well to prove it. We're showing that it's true. So g of f of x should equal x. So it should, in theory, equal x. So let's plug in f of x. F of x is x cubed plus 1. So now everywhere over here in the g function, I'm going to plug in an x cubed plus 1 as my new x. So instead of x minus 1, it's a minus there, to 1/3, I'm going to put in here x cubed plus 1. And now simplify inside of the parentheses, and this is all supposed to equal x. So if you simplify inside, you have a 1 minus 1, which is really 0. So I really just have x cubed inside of there. Of course, what's x cubed to the 1/3? That's just x. X equals x, and you've proven it. So you've done it both ways. You've shown that that really is, those are inverses of each other. In fact, I could call this, instead of calling g of x, I could call it f, the inverse of f of x, if I wanted to. Find the inverse of the function. So, and by the way, this is supposed to go on forever there. It's like a square root function kind of thing. There it is. In fact, it is a square root function. What is the domain of f? So domain looks like it starts at -2. So -2 to infinity. It goes on forever to the right. Draw the identity line. So that's always the line y equals x. So it has a slope of 1 and a y-intercept of 0. So it should cross right there. It's a dotted, that's supposed to be a dotted line, looks something like that. So I draw on the identity line. It's always the line y equals x, always. Slope of 1, y-intercept of 0. Reflect that across the identity line to draw the inverse. So If I take this point right here and reflect it over the line, it's going to go to right there. It looks like it goes through this point right here, so it's going to go through this point right here. Trying to pick out nice points. It looks like it crosses right there, and so it's actually that's going to reflect onto itself. It's on the identity line. It looks like it almost crosses right there, which means it almost crosses right about there-ish. So it looks like my new function will look something roughly like, sorry, it goes through that point, something roughly like that. And that does look symmetric to the identity line, so I think that is right. Find the inverse. So to find the inverse, we're going to pretend this is y, right? So so y equals square root of x plus 2, right? But we switch the x's, switch x and y here. So it's going to be x equals square root of y plus 2. I'm going to solve this, which means solve it for y, which I'm going to square both sides. I get x squared equals y plus 2. Solve for y, I get y equals x squared minus 2. That is the inverse function, but we have to think about domain, because think about it. This does look kind of like the parabola y equals x squared minus 2, but it's only half of it. I only really want the part where it looks like x starts at 0, so the domain of this one, the domain is part of this answer, is going to be from 0 to infinity. And if you're struggling as to why that is, look at the range of the first function. They didn't ask you, but if they asked, this is the domain. If they ask for the range of the first one, it looks like it goes from 0 to infinity, and it includes 0. So what happens with inverse functions? The domain and range switch. So if the domain was that, the range is that, now on this new function, the range has become the domain because it's an inverse. The domain has become the range, so the domain should be from -2 to infinity, just like the range, the domain was on the other one. And I think that's the end of the